All right, day three. Today's a little bit different. My microphone is very different and a lot worse than at home, but anyways, let's do it anyways. So day three, gear ratios. You and the elves eventually reach a gondola lift station. He says that it will take you to the water source. Um, as far as it can bring you, you can go inside. Okay, cool. You find them, and it seems to be a problem. They're not moving. Okay. So you turn around to a slightly greasy elf with a wrench and look surprised. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. Okay. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. Okay. So we get the schematic. It consists of visual representation of the engine. There are lots of numbers and symbols you don't really understand, but apparently any number adjacent to a symbol, even diagonally, is a part number. So it's a grid problem. Okay, so the dots don't count. Okay, so 467 is diagonal to a star. 114 does not have any adjacent symbols, so ones that are not part is 114 and 58. Okay, so it's a grid problem. Okay, so what we'll do is we'll make a grid of integers, and they seem to be positive numbers only here. So whatever. Oh no. Hmm. I'm just thinking. Maybe it's better to make. Oh no, because part two will probably involve me knowing what these symbols are. Hmm. Do we do it with integers? Okay, we'll do it with integers, and then maybe maybe we know what these are. So not not too worried. Maybe slightly worried. Okay, anyways, let's do integers. So basically on a grid here, I'm going to do like 467, and then on this part also 467. So I'm going to put some repeated numbers in there. I think I'm also going to add, I tend to do this, but I think I'm going to, okay, let's just do a grid. Okay, so we have the input and input file, the examples there. Great. So we have to allocate some stuff. So allocator equals standard dot page dot heap dot page allocator. Okay, so we want a grid of usize. So we're going to say var grid equals, and we want an array of arrays. Try allocator dot alloc. Okay, we want to allocate not u32s, but an array of u32s. So we have an array of arrays. We have an array of arrays. Does that work? Yeah, right? Yeah, that should work. And we want that to be an array. Oh, but what sets the size of the ones inside, right? I'm just trying to remind myself, right? Because we want to declare. Oh, I think do we have to declare the. Okay. Okay, let's declare. Hmm. I need to really remind myself how this is done. Okay, so we have input dot. Let's input dot length, which should be 10 or 9 there even. And let's just debug some stuff, right? So I want to see what the length is, grid.length, and I also want to see what grid0.length is. Okay. Oh, nice. Okay, so we have 10, and then yeah, this just seems like random stuff even. So maybe not ideal. Hmm. Okay, so I mean the first one's correct. Hmm. I think we need to allocate a bunch of. Hmm. Okay. Okay, this is fine. Now what we do is we say that for each one, so for grid, like grid 0, is going to be like the try allocate. Yeah, okay, so that's all good. So let's do that in a for loop, I guess. For 0 dot dot grid dot length index, and we're going to do grid. That's the index is equal to try allocator dot alloc uth2's input 0 dot length. I think that's probably correct. Let's defer the freeing, right? No memory leaks. Defer grid dot no allocator dot free grid. Let's defer the oh, actually, right? Does this cover everything? Like including the sub allocation? Maybe. You know what? Let's do an arena, which is equal standard.heap.arena allocator. Okay, dot init, and we're going to take the allocator. It's probably a try in there, right? Init probably. Maybe no need for a try then. Okay, we have arena. We're going to do try arena dot init. Yes, we're going to do. Let's change that to a. Change this to a const allocator equals arena. It's allocator. And we're going to defer arena dot d init. Yeah, I think that should cover everything. It's probably not important. The operating system does it anyways, but okay, let's see if it runs. Do we get any crashes? Okay, arena dot allocator. What is this expected? Found const. Does it need to be a var then? Do they all need to be vars? Maybe. Alright. So we have 10 and 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's correct. Alright. As we go along, we might as well say row. I'm going to say var row. This is row here. We might as well, put some stuff in there. What we're going to do is we're going to go through. Oh no, let's just initialize, and then we'll go through. So for 0 dot dot grid dot length, let's call that I, and for 0 dot dot grid 0 dot length, let's call that j. Let's say, but here we want to store numbers. For char equals inputs at I j if char is bigger than or equal to 0 and char smaller than or equal to 9, then we want to actually say that grid at I and j is equal to, oh, yeah, but how do we know what the number is, right? Because that's annoying, isn't it? We need to actually read it until we stop. Yeah. Okay, so this is fun. We're in a row, right? The numbers don't span multiple, so we're going to say current number equals 1. We'll do 1 because we might want to times some stuff. Then yeah, here we're going to say we basically want to add this number on. We want to say let's do because what I want to say is current number times or equals 10, so I can shift everything over, and I want to say current number plus equal char minus 0 there, but this will not be ideal. Oh, unless it starts with 0, yeah, of course. So the first time around times by 10, we times by 10 is 0 times 10 is that. If we add this on, then times by 10, yeah, this is good. Okay, else, okay, so literally everything else we want to say that grid at I, that's the row j minus 1, because we want 4 equals current number and current number equals 0 again. Okay. You know what, let's print the grid. Just to see if we're on the right track. I think we are. Let's I need to do an S there for this. Okay. Do you compile? You don't compile. Variable. Oh, right, because of this. So let's make it a U32. Valid S. Okay. Let me remove that. No, it needs an S then. What do you want then? What if I do any? I think it's a bit confused. Okay. Pretty cool, but then it dies a little bit, doesn't it? Okay, integer overflow. Love to see it. We love to see it, but oh, because it could be -1, right? I guess. I guess yeah. If we're on the first thing, we don't want to. Else if j is bigger than 0, we can try that. Okay, good. It's not very pretty, but we have. Are we printing the input anyway? Oh yeah, we are. So that's not great. Let's not do that. So we have a way too big a number, 467. Oh yeah, that kind of makes sense, doesn't it? Yeah. Because we go, this a number, yeah, this a number, yeah, this a number, yeah. Oh, this is a bit more complicated, right? Because we don't just want to set it in one place. We want to see like how many digits did you span? So we can do this using division of some kind. We want to find the digits in a number. Oh God, how do you just divide by 10 until you can't? Is there an easy way to do this? Find number of digits in a number. Oh God, I think, is it just dividing by, oh, log. God, I'm silly, yeah. It's just log, isn't it? Right, because log calculator, right? Log 10, base 10, yeah. Log base 10, if we do 2, 3, there you go, equals, oh, this is great. Just give me a calculator, please. All right, so yeah, if we do this and, oh wait, that is very incorrect. Never mind. What did it say then? Recursive solution. Oh God, this is easier than it sounds, right? Find the number of digits in the digit. Yeah, I felt like this is what log was for. Hmm. Yeah, can we just turn it into an integer and then find the size? No, let's do this properly. Yeah, log 10 number plus, oh, plus 1. Du, 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 du. Yeah, yeah, so if we, yeah, we have to add 1. If we do like a bigger number, 4. Floor plus 1, 4, yeah, that works. Okay, now how do I do logs in Zig? Zig log 10. Math, okay. Standard.math.log 10. There it is. Okay. So we're going to do var digit count equals, we want to do standard.math.floor, standard.math. Let's move this to the right a little bit. Dot log 10. Log 10 of the current number. Great. Log 10 of the current number plus 1. And digit count. Yeah, digit count. See how many times we do this for. So 0 dot dot digit count k. So this is like what you do k minus 1 minus k, what's current number? And then just out of curiosity, I've got to print current number. I might like severely be overcomplicating this, but okay, let's see what we get. Expected value float found U32. What? Okay, so do we need to do this as, I don't know, float? Yeah, type conversion. Float, doesn't it? Doesn't like float. Use of undeclared identifier float. F32. Yeah, that might do it. Expected type F32 found. How to as F32. Do you work? So we have, oh, not. Yep. Okay. So I mean, this works, right? If we don't do the floor, and we plus 1, I mean, this will probably crash, right? Yeah, definitely. Definitely crashes. Current number 467. It does actually get there, right? Because if it's an integer, it will be okay. Reached unreachable code. You did. Okay. Oh, and current number bigger than 0, because we don't really want to, log 10 0. That's not great. Okay, I think that worked. Yeah, it works because current number is U32, so it'll just chop off integers anyway. So 4, 35, 63. All right, cool. So we have something 467, 467, 467 there. Okay, and then I guess we want to do this, but then we also want to set it to whatever it is right now. Yeah. So if input at I, j equals a dot, then we want to say input I, j equals 0. Else, and we're going to have to repeat this code, but okay. Let's say, I'm going to be risky and say 1, because I assume there is not like a singular, just 1. If there is, we are a little bit silly, but it doesn't seem to be just like a singular one. Alternatively, we can make them typed and go into the negative realm, but fine. Okay, this will work. And we want to copy this code for this else branch too. All right, let's see what we get. Okay, can I assign to constant? Oh, not inputs, grid. Grid. Okay, 467, 467, 6700. Okay, and then we get 1 there. 001. So 00. Is that one? Oh no, that's perfect, yeah. All right, we have a grid. We have a grid. Great. So now we have to iterate over the grid. And iterate over the grid. If we find a number, that is different from the last number. Yeah, so we're gonna have a little bit of weird logic there, but it's okay. 0 dot grid dot length. I for 0 dot grid 0 dot length j. And we're gonna do last number, which is U32, which is 0. Okay, so if grid ij is bigger than 1, right, because 1 can be a symbol, bigger than 1. Okay, so first of all, let's just set last number equals to grid ij, and also we want to do it, and last number. Can we increase j? Like, point would be that maybe we could increase, but anyways, last number is not equal to grid ij, otherwise we would add them repeatedly. Okay, so over in here, we want to look around the grid. Oh wait, no. Oh, this is a little bit harder than I thought, because we need to, if we here, 467, 467, 467, yep. Then we need to like look around the entire thing, not just oh, tricky. Okay. So maybe we don't want to say this here. Oh, all right. Let's just plug that in before we die. What we don't want to do is stop it from going forward a number, because if it stops going forward a number, we might miss out. Well, we will miss out some. All right. Top charge now. So, okay, it's not last number here that we want. We'll get onto that. We'll just ask if it found a symbol for now, and then we'll do the discounting, like repeated results and stuff. Okay. So we need to look around current num for 1, remember, because we set the symbol to be 1. So I think I'd just do literally the manual check, like 1, 2, 3, 4, 5, 7, 8. Or do we do a for loop? Okay, for minus 1 dot dot 1. Around I. Let's say around I. Be super lazy with our names. Around J. If around I is equal to around J, we continue. Okay. And also if right, we need to do a couple of extra things, right? If around I is equal to minus 1 and I is equal to 1 to 0, then we also can actually, let's just do these all, or around I equal to minus 1 and I is equal to 0, or around J equals to minus 1 and J is equal to 0. Like we're going to continue on those. Okay. God, there's so much nesting going on. We're going to continue, otherwise we're going to say if the grid at I minus around I and J minus around J equals to the number 1, we're going to do a debug here, dot print found symbol, and then num something number is going to be grid I, J, and the semicolon there. And get rid of this, get rid of this. God, there's so many for loops. Okay. Type view size cannot be represented by integer. Oh, really? You can't do this? Okay, well, extra laziness. 2, 0, 2, underscore around I underscore around J. So we're going to say around I is equal to around underscore around I minus 1. Yeah, but around J. Cool. Oh, okay. Got some integer like that. Let's do this as I32 and as I32. So it says so it doesn't do that type of thing. Ah. Well, oh, type coercion, right? I see. Okay, never mind. Let's go back, go back, go back. Around I is equal to 0, around J equal to 0, and what we're going to do is take away 1 right here, minus 1. Okay. Okay. We still crash, but can we not crash, please? Let's get rid of this. Current number. Oh, you are printing here, aren't you? Yeah. So let's not. So I minus around I. Oh yeah, so this would actually be a plus, right? Yeah. So it would be a plus. So this has to be a plus. This has to be a plus, and if around I is equal to 2, right, and around j is equal to 2. Okay. Still going. I got it here, so, huh. Oh no, from equals to 1, or equals to 1. Right, if they're equal, doesn't matter, because it's kind of like an offset, so. Okay, what was it complaining about? Let's debug. X, Y, probably just doing the maths quite wrong here. And stuff inside here. There's a lot of indentation here. Alright, starts 1, 1. Because right, so it goes 1, 1, and it's going to do I minus this. But the error is integer overflow. So what if we add first? I wonder. This might work. Because then at no point is it a negative? No. Oh wait, no, now it crashed on standard there. Oh, so minus plus 1 minus this. That's pretty cool. Okay. So, found a symbol for number 467. Did not find one for 144. Concerningly, did not find one for 35. Did find one for 633, 617, and then it kind of sizzled out. It did not want to keep going. Next we're out of bounds. Oh, right, because we need to account for that upper bound too. Now this whole thing would be easy if we just didn't have those edge cases. We just, yeah, this would all be a lot easier if we just had like a little bit of padding to the left, a little bit of padding to the right. You know, let's do that, because then we can get rid of this. And we can just keep that, knowing that will never overflow. Okay, I like that. Plus 2. Plus 2, 1 on the top, 1 on the bottom. And each time we assign something here, we also need a plus 1. And we're going to do from 1 to grid of minus 1. Same here, right, because we have a little bit of padding. Minus 1. Oh, grids are a length now. Grids are a length, which will be 2 more than it needs to be. So we're going to do to take away 2 there. Just to make sure we're all good. Let's standard.debug.print the grid, any dot grid. All right, where are we? Oh, when we look for input, we have to minus 1 on both sides, right? Because we have. Wait, no, shouldn't do that. Should it? Should minus 2 there? Yes, that was it. Okay. Stuck this away. let's take a look. So, very wrong, very wrong, very wrong. Oh, but that's the top. Right. Hmm. Yeah, so that's the top. Ah, okay, oh, so let's actually do grid at I, just so we don't, oh my god, what's going on? 0 equals 0. And we're going to do grid.length, grid 0 length minus 1. And what we're going to do up here is going to say for 0 dot grid 0 dot length I, and we're going to say grid 0 0 at I equals 0, and also for grid dot length minus 1 all the way. Okay, what have we got? Another out of bounds error. And we get an out of bounds error where here, oh, because yeah, this needs to be minus 1, minus 1. Yep, minus 1, minus 1, minus 1, minus 1. Okay, there we are. So, there we go, let's fold that as well. Okay. Are we printing, where are we printing this grid? Oh, right here. Okay, so we have the top row is 0, and then 4, 6, 4, 6, 7, 4, 6, 7, 4, 7, 0, 0. Then we have a lot of kind of unknowns. That's just a really big number. Why? 4, 7, 7, 0, 0, and then 1, 1, 4. Right, I feel like we're probably not looking. Yeah, this feels wrong somewhere. This feels wrong. You know what? Okay, let's just ditch the padding. Thought it was easier, but let's not do that. So go back, go back, go back. Here we are. Never mind, ignore that. So we're at 1, 1. Yep. And then or if. No, we're doing this quite wrong. So let's not. Okay. Pretty weird. You know what? Let's do this manually. Let's just say, so if I is bigger than 0, yep. What are the edge cases, right? Oh, no, can we bring that back? And let's just start this inside bit again, because like it's just being confusing. Yep, unused cap so far. And let's actually do a minus there. God, really off of it today. Around I, which is an I32. Oh, which is equal to around I minus 1. Around J. Around J. Okay, so what we're going to do is debug.sprint. Let's just make sure that you work before we move on. Okay. Expected, yeah. How do we change that? Zig use size to I32. Yeah, so I wonder if there's a way to do this int cast right. Okay. Can I do this? Does this work? Converts an integer to another integer while keeping. Okay. Okay, I guess because the return type is kind of implied there. Typed I var around I equals typed I minus 1. Okay. And let's do the same here. Typed J around J, typed J. Okay. Alright, there we go. So in cast, we learned something new. What we do want to say is if around I is equal to 0 and around J equals to 0, we want to continue. Where else do we want to continue? Like when we can't access the left side, which we could probably do up here, right? So if around I is equal to minus 1 and I is equal to 0, that means that means we can't go to the left, so we want to continue up here. Another time is when we're on the right side, so around I is equal to 1 and I is equal to grid.length minus 1. I want to continue. Continue. Great. So what else? What else do we want? We want this. We also want to say if around J is equal to 0 and J is equal to 0. Actually, minus 1 there, right? Continue. Next up, around J is equal to 1 and J is equal to grid 0 dot length minus 1. Continue. And just to really see if we're doing things correctly, we're going to do input the grid at I and J. Okay. No, there's not really an easy way to see if this is correct, I guess. We're just going to ask if grid at I minus around I, J minus around J. This should never overflow. Go into negatives. So equals 1. Debug. Print. Found symbol num something. That number is going to be grid I, J. Okay. Incompatible types. Yeah, I suppose it is. Can I do this? Like, I as an I32 equals int cast of underscore I. J. Does that work? But then I have to. Oh, man, really? Okay. Yeah, okay, so we do this, and then only here. Alright, let's call it offset, which is a u size, which is I minus. This is not nice, is it? Yeah, I mean, I feel like I'm just doing a lot of casts, but it's okay. Around I, u size, which is a u size of int cast of around I, and around I, u size, and we can do around J, U size, around J there, U size. Okay. Okay. Attempt to cast negative value to integer. Okay. Oh, of course. Yeah. Uh, Is it complaining that we're doing, like, we're taking away stuff? So if I do standard.debug.print, yeah, it will complain of that, won't it? So it's probably easier to, you know, keep these as, get rid of the -1 there. Yeah, let's do that. God, really. This is not going well today. Okay, so if it is 0, and if this is not 0 but 2, I actually caught an error there. If this is, if around I is 1 and you are 1, you can go away. If around J is 0 and if around J is 2, okay, around I, around J. God, can you stop? What's going on? Oh, because it could be, yeah, so +1. Yeah, we have that same issue though. Sorry about that. Index out of bounds. Oh, I thought we would account for that, didn't we? I thought we would. If around I is 2, and the grid reaches it, huh. So .bigo.print x, which is this. Let's see, just before we crash, we go, yeah, 10. But how does it get to 10? It goes, I feel like it should never get to 10. Right, yeah, because 10 is definitely too much. Okay, well, just, oh, wait, we might be committing, just the error might be up here even. Nope, that's all good. Okay, let's think. This should it be -1? Yeah, -1 plus around. Yeah, that's it. Right, because we want to just offset it slightly. And because of our ifs, we should never actually reach that step and overflow. We've reached that step and overflowed, great. When? God, I'm really struggling. Okay, when I is 0. Oh, okay, when I is 0. Yeah, let's do plus around I, only after minus the 0. Minus the 1 even, sorry. Great, great, we've got some stuff. Okay, we found a symbol on 35. Yep, okay, we seem to have skipped one, but okay, found a symbol on 35, we found one on 664. Okay, one on 598. Wow, okay, so we are missing a lot. So I mean the 467 should find some stuff. but it didn't. And it didn't. Why? I mean, maybe if we delete these for now, let's just see what happens. Okay. Yep, prints a lot of stuff. Okay, something here is wrong. Okay, so first of all, debug print none is grid I j. Okay, 467, 467. Okay. The point is that j will be, around j will be, or actually no, j will be 0. Oh no, I will be 0. Right, yeah, that's the row. I will be 0. Okay, so this will continue, and I need to just know the ones it does check. Debug.print checking. Let's do that and this. I guess I haven't done this type of stuff in a long time. Like the grids and stuff. Let's do that. Oh god, what did I do there? Okay, yank inside your square brackets. Okay. Okay, it's checking. Okay, so the first two. For the first one, it didn't even check anything. So that's not great. Because it definitely should check some stuff. Oh. Okay. It only... What? It like only ever reaches it once. That's weird. For the first I, which we're gonna like that should skip 0. And it should go on to 1. Okay. And also this seems weird. Oh, wait. Let's just change this to be around I, around J, so we actually know what's happening. Checking 1 0 1 0 1 0 1 0 1 0. Are you gonna complain that I'm taking away 1? You are. Great. So wherever we see 0, let's just imagine a -1. It's weird nothing checks there, and only here it only does it a little bit, a couple of times. This, okay, I mean, yeah, this should be happening a lot more times. What to do about that? What do we do about that? To do about that? Seems like I'm dealing with just issues that I'm not meant to be dealing with right now. Like these are not the issues worth dealing with. I mean, okay, this seems like a lot of work for maybe not a lot of gains, so I think what I'll do is just come with that. Right, we'll comment that, and we'll just do it manually here. Like we'll do the numbers that we want to check. Like we'll make the numbers that we want to check. So we're gonna start with. We still need to do checks, right? We need to do I. If I is equal to 0. If I is equal to 0. Or actually, if I is bigger than 0, I'm just thinking of what it needs to check now. Ugh, man, this is really annoying me. This is really, really annoying. This is really annoying that this is not working very well. So basically, around I equals -1 and I is 0, because then you would do like you would do 0 -1 I minus 1. Yeah, that's fine. Is it this? No, that can't be it. So let's just check. Which one's the test check? Checking around I. Prints once, and it checks around I. It checks for doesn't check 0, good, checks 1, but then it doesn't check 2. Oh my god, are you non-inclusive? Yes, you are. That was it, wasn't it? Now it goes. Oh, that is silly of me. Checking. Yeah, it's not inclusive. Oops. That would have done it, wouldn't it? Now it checks one to the right, the one down, the one diagonal, and then the one. Yeah, that's perfect. Great, 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 great. Oh, just those little bits of not knowing language really just get you. Okay. Okay, so found for 467, it found 35, it found 633, it found 617, it found didn't find 58, good 592. Oh, diagonal, yeah. 755 and the other two, great. Oh, okay, good. God, that took so long. Let's just comment, just in case that we are not done here. Okay, so now what we need to do is a sum, right? They want a sum. We take that number and we add it on, and we just keep track of the last added number, make sure it's not equal. Two numbers are not part of a number because they are adjacent. Okay, their sum. Okay. Can we? Okay. Oh, that took so long, man. Okay, 0. And we're gonna do last added number U32 is 0. We're gonna say if last added number is not equal to grid I and j. Oh wait, or do we just continue up at the top? Like, do we just, if we do find something, we move? Oh, no. Okay, let's not get complicated. If last added number is not equal to the one we are checking currently, then we say part 1 plus or equal to grid I. Actually, last added number equals grid I j. Last added number. And then let's do standard debug.print part 1. Oh god, I'm really out of it. This should not have taken this long. This should not have taken this long. I am sorry if you actually sit through this on this bad microphone. And my throat sounds really bad. And God, no, integer overflow. Are we adding too much? Oh, is this where usize actually comes in handy? You know, last video I kept saying, you know, usizes are overkill. Uh, but no, that's too high. Oh, okay. That's annoying, but okay. What can we find? So you're good. You run 4, 3, 6, 1. 4, 3, 6, 1. Okay. What about this could throw me off? What about this could actually throw it off? I mean, nothing jumps at me right now. Nothing jumps that, you know, could be something worth throwing off about. But let's just do some console logs here. Standard.debug.print, adding another number. Last add number. Oh, not a new. Let's get the big one because we know that one works. That's fine. Oh, right. So I mean, some of them. Oh God, some of them are not initialized. Huh. You see, like we're getting. So it must be an error here. Must be an error here. I mean, I could do a really ugly check, but you know, no. Let's do things properly. Let's do things properly, and let's print. Let's print the grid. Let's print the grid. Let's print the grid because one of them is some parts are not initialized and some are. So standard.debug.print. We're just going to print grid I j, and this needs to be this like destruct type thing. Standard.debug.print new line. Oh, yeah, it needs that empty struct, doesn't it? Yeah, that's it. Okay, let's scroll up. Okay, that's not very pretty. Yeah, that's like just unreadable, isn't it? Let's do a comma space. Get the example inputs instead. Are any of them very big? No. But they will be on this. And oh wait, hold on. Let's get rid of the adding there. Yeah, we see quite a few. Especially, okay, let's see, do we find one? Oh, do I need to zoom out a lot? Two five five, 255, 255. Okay, so is there a 255? Yeah, this is pretty strange. I mean, on this line. Oh, right. Look, because that's on right on the end. It's right on the end. Oh, okay. I see. I see what's. Oh, that's hello. It's right on the end. If the number's right on the end in our initialization loop, we never, well, initialize it. So yeah, pretty interesting. Let's just comment this out. And basically, if we go around, and let's put the U up here, and then we say, if we've gone and yeah, right, that makes a lot of sense. Yeah, if we've gone around the loop and we say if current number is not equal to 0, then actually we want to go up 1 right to the end. Yeah, we want to go up 1 right to the end. Okay. We want to go to the end of the grid, so we want to go grid 0.length. We're going to take away 1. We're going to minus k. And do, yeah, that feels better. It feels right, I think. Let's just uncomment that. We might get a couple of compiler errors. No, we don't. But we still get those big. It's just saw a couple of them there. Yeah, 2717, 271, 271. Yeah, like this one here, still the same. So this didn't really seem to work. We went around. It's not 0. We went around, still not 0. You know what? Let's just debug print line. Not 0. Well, so what are you? Current number. And you know what? Let's do this and just add like a 5 there. That will be much easier to see and understand. Okay, yeah, see the 5. Not 0, 5, but then, oh, grid minus 1. Grid minus 1. Okay. I think that does it. I think that does it. Okay, so that still works. And let's get this. Okay, it's much smaller answer. So okay, usize did not save me this time. I was bragging about it, but I guess not. No, come on. Still not going. Still not doing it. Day 3. Day 3. It's just already a nightmare. I mean, quickly looking, I don't think I'm overfilling anything right now. But I think it's okay. That feels like the correct grid that they want. Right? Yeah. Let's look at 374. Do we find a 374 here? 374. Yeah, 374, 374. On the line, same line as 255. Yeah. That's all good. Don't have that as an excuse anymore. But what did it say? Answer's too low. So maybe we're not including that. So what I'm going to do is I'm going to get the example inputs again. So this has not gone long. This has not gone on for long enough. And what I'm going to do is I'm going to say that this is ... You're a 5. You're a star. Let's get rid of you. And we should get 467 plus 5, which is 472. Okay, works. Okay, so then that leaves me with like no idea. That is something. It's gonna be such a tiny little edge case, isn't it? It's gonna be okay. So what if there's a minus there, but a dot here, right? We're just gonna add symbols of just until we see. Okay. Oh, we took away 467. Okay, let's add 467 up there. 4361. Okay, yeah, that works. That works. Huh. Yeah. Let's add a number that's, yeah. And it says it's too low, so we need to add more numbers. So it's not like we're counting the same thing twice. But yeah, that's really, really annoying. Right. What to do, what to do, what to do. I can't really think of an edge case that would make this happen. Is it if numbers can like go close to each other? But to be fair, it doesn't even seem like that's the case here. Like in this input, I mean, if like there was a number above it, yeah, it does not seem like that at all. We are definitely resetting last added number, are we not? Last added number. It's too low. Huh. Okay, I think else last added number equals 0. You know, I think that might be the case, right? Because it might be the case where you have actually the same number close to each other that now we're forgetting to add up. Can't remember what the last solution was. Was it this? Oh, maybe it was this, but I can't remember now. I cleared the console. Uh, just to be sure, let's console log view, and yeah, let's get rid of this. Oh, it's the exact same. That's really annoying. I thought that was it. Huh. So if it's bigger than 1, then yeah, we try and do that. No, if it's bigger than 1, oh yeah, bigger than 1. Otherwise, yeah. Very frustrating. This has been quite the day. Um, yeah, even had to take a cut to actually like figure out what the hell is happening. Went on Reddit just for a couple of hints, and I found this test grid that someone had made. And if you notice here, I'm not adding these bottom ones, right? And I'm not doing that because of the boundary checks. Wow, like yeah. So let's try and fix that. Let's see if we can get this grid to work to add those extra two ones there, because it's just the boundary checks are wrong. Because here, right, if we are, if we're at on the bottom left corner, we want to check above to the right. Yeah, we don't want to check to the left. So, yeah, I think it must be these checks here. You see? Okay, actually, I'm gonna do standard.debug.print checking this. So we're gonna check. No. Okay. Let's. I wonder if it works. We get the same result. Yeah, the ones aren't added like that either. So we go I is 1 and J is 0. Let's check. So we go here. Okay, if around I is 2. Okay, around I is not 2. It starts off. Hmm. Okay, I need to print some stuff. Stand.debug.print checking these. Okay. And that. Okay. Actually, yeah, just around I, around J, -1. It's going to complain if I do that. So I'm just going to, whenever we see a 0, we just have to -1. No heads there. And up here, we're going to do standard.debug.print num. Oh, even that. Cool. So the number, it does 5 or 3. It skips over the 1. It skips over the 1 because oh, it's not even a boundary check issue. Oh, that's devastating. Yeah. That's so annoying. That's just really annoying. Ah. Alright. Let's change all of these. Right, wherever we see I32, we're gonna do a U32 instead. Oh, other way around even. There we go. I32. Now, when we initialize the stuff, wherever we see a dot, that's going to be just 0. If it's not a dot, it's not going to be 1, it's going to be -1 for symbols. And I think this might actually help us with part 2, because they're probably going to do something with symbols, right? Any symbol like this, yep. And here, we want to check if it is bigger than 0. Oh, if it's off by 1, I'm gonna cry. Ah, expected digit count. Digit count. Digit count. We're in which line? 21. Oh, so actually here, yeah. Oh yeah, but current number can stay U32. Can we do? How do we do U32 to I32 in Zig? Oh, int cost? Yeah, probably. Yeah, that was it. Var typed current num, which is an I32 equals int cost of true and I32 of the current number. Oh no, we don't need that, do we? So it just figures it out. Type current number. Okay. We're probably going to need this a couple of places. Current number. Yeah, let's do this, that, that there, and then we also need this here. 3 is this down there, yep. Type the current number, and then here type current number. Great. And let's see, do you compile? Don't compile yet. Last added number i32. i32 there as well. Well, that's great, isn't it? Do we even check a number here? What's going on? Checking 1. Okay, good. 1, 1, 503, 503. But then we're not adding any of them? Like, okay. But, oh, if it is equal to -1, because we now do that, don't we? We want the adding, we don't want this console log. Let's see. So we add 1, 1, 503. Okay. Okay. I think that was it. That was the fact that I didn't account for there being a 1, you know? Go on, please work. I think our solution was off by 2. If this is correct, it was off by 2. Oh, very nice. That was only, 1 hour of my life. Oh, wow. I do this a lot, actually. It's something I need to get better at. Focusing on the wrong issues. Like, of course, I think the boundary checking was correct. We checked it a few times, but I didn't check further parts above of the code. Yeah. Okay. Anyways, finally, part 2. The engineer finds the missing part and installs it in the engine. As the engine springs to life, you jump in the closest gondola, finally ready to ascend. You don't seem to be going very fast, though. Maybe something is still wrong. Fortunately, the gondola had a phone labeled help, so you pick it up. Before you can explain the situation, he suggests that you look out the window. There stands the engineer holding a phone in hand and waving with the other. You're going so slowly that you haven't even left the station. You exit the gondola. The missing part wasn't the only issue. Only the gears in the engine is wrong. A gear is any star symbol that is adjacent to exactly 2 numbers. Okay, the gear ratio is the result of multiplying those 2 numbers. This time you need to find the gear ratio of every gear and add them. Oh god. Okay, this doesn't look too bad. Consider the same engine schematic. So we have a 467 star and then 35 there. We have this one. Oh, that one's not adjacent to any number actually. That one's not adjacent to any number. I think we can inverse what we're searching for here, right? We could now inverse and just search for the star. We could do it like a -2 or something. Do a search for the star and then search for two numbers around the star. Yeah, I think that could work. And we take the exact same boundary logic that we had from the other part. In schematic, there are only 2 gears. The first is on the top left. Okay, the second gear is in the lower right, yeah, because it's adjacent to 2. Okay, that doesn't seem too bad. What I'm going to do is I'm going to get that back, and actually I'm going to copy this because I want to keep part 1 as is. So let's just fold inside the brackets. Oh, not quite those brackets. Let's fold inside here. Okay, so first of all, we need to change our initialization, don't we? -1. Oh, and before that, we're going to break up part 1 if we do this. Smaller than or equal to -1. Very, very nice. Okay, and up here, if it's a dot, else if and then else this just gear. Yeah. Else if
inputs I j is equal to star minus 2. And let's just copy that because we didn't do the cleanest code for this. There we go. Just let's make sure that still works. For part 1. Wait, why did that change so much? Oh, because we're doing it like again down here. We still haven't done it. Okay. Right. Okay. Let's just get rid of that just to make sure that part 1 is still working. 4316, 4316, yeah. Okay, very cool. So what we're going to do is we're going to check if grid I is equal to minus 2. We're checking for a grid. God, sorry. Yep, boundary checking, yep. So I mean, I'm going to assume it can be just 2 numbers. Okay, could be wrong. So var prev gear f2 equals 0, I guess. Here what we're going to check for is if it is bigger than 0, right? That means it's a number. And I don't think we need to do this last letter number stuff, so I'm going to get rid of it, and I'm going to get rid of this extra one. Just seems like dead code. If it's bigger than 0, then we say if last gear, what did I call it? Previous gear, yeah. Previous gear is bigger than 0, so at this point we have found a number. What we're going to do is we're going to say part 2. I hope this doesn't overflow, doesn't get too big, but it might do, so let's keep that in check. So part 2 is this grid. So yeah, exactly this here. Okay, part 2 times that. Previous gear is 0, right? Because we found the second one. Else, kind of like this, but previous gear equal to that. All right, this might work. Might be rather okay. Let's get rid of you. Okay. So we just have part 1, part 2. We still have none being printed from somewhere. From here. Yep. Okay. Part 2 not really working for us. Okay. Part 2 not really working for us. Let's just check. I mean, we should be checking some stuff. Okay, minus 2, minus 2, minus 2. Does that check the right number? 1, 2, 3. Yep, that's all good. Okay. Okay. So if 3 is bigger than 0, at this point we found a number, right? Found number. Let's just found number. Yep. So we found number 467 and then 35. So it seems like I'm just doing very bad maths. Oh yeah, last check number. We still have to kind of account for that, I suppose. Yeah, because I guess we go here and prev gear not equal to this.
No, it's still checking. So, oh, else if like find this prev gear not equal to grid, right? Because we don't want to check the same numbers twice. Oh, it's still doing it. Okay. Oh, because of this up here. Uh, this is pretty weird. So we found a number. If previous gear equals 0, let's take you. Let's put you here. So found number 467. And it sets it right 467, and it doesn't go here. Well, it does. It probably does, but if else probably does go into those places. I'm just not looking. So it goes else, right? Previous gear not equal to that. Okay, we're setting 463. Then what we're saying is, oh, right, plus or equal to, yeah, this looked very silly, doesn't it? Maybe I should read code, like, actually. 467. Oh, that's wrong though. Wait, so the second gear ratio is that. Adding up old gears, yeah. Okay, so else 467 and then 35. At which point we do previous gear times current one. We do gear equals 0. And it does an else 35. Ooh, but yeah, the thing is, okay, maybe previous gear has to be unset every time we move over, right? Every time we find one of these, yeah, previous gear. It might be useful actually to just move this into local scope. Okay, I think that's it. Yeah, because otherwise, if you have one gear with just one, yeah, it's still, yeah, okay. Think, I hope, at this point on the bit side, but I hope this is good. All right, let's check it out. I mean, that looks like a big number, but you know, timesing, adding stuff, please. That's not the right answer. Oh, come on, man. Okay, we didn't try very hard there yet. Okay, you definitely give me the right one for both. Yeah, 467 835. 467 835. Yep. Yep. 467 835. And yeah, I didn't count that one. Good. Can you count that one? What is that? A potential to be 3? Let's go. There are 2 gears. Okay, let's just read a little bit. A gear is any symbol that is adjacent to exactly 2 part numbers. Ah, right, exactly 2. So I think we're going overboard. So what I'm going to do is I'm going to say that for each one, I'm gonna make this a bit better. The product, so 2 equals 1, and what we're gonna do is if we do find it, I think might be wrong. Found a number. I'm just gonna do product times equal to this yank to that, but I'm also gonna have num of nums. Seems weird, but okay. It doesn't need to be typed, but fine, whatever. Fine. Usize. After we're done, right? after we are done with this loop here, if num of nums equal to, then we say part2 plus or equal to the product. And here, num of nums plus or equal 1. Okay, not great. That's not great. Product starts at 1. Oh, but it might count the same one multiple times. Might count on the same one multiple times. For last brief gear, I set 2 is 0. Then we say if previous gear is equal to this, then we continue. Because we don't actually want it. Otherwise we say previous gear is equal to this. That should hopefully, that should do it. Is that the right example answer? Yeah. Okay. I hope that's the full input. Yep. Okay. Still wrong. Okay. I'm gonna go figure this out and I'll come back. Alright, so I think I figured it out. I went back to this example that I showed you in part 1 and manipulated it a little bit such that we only have 78 times 78 being valid. Because, like, you can see already that if I just keep the previous value and I have the same value twice, 78 times 78, that's not going to get me anywhere. Also, this 2 times 2 times 1 times 1, if I kept previous value 2 and then didn't check the 2 again and then had the 1s, it could mess things up. So I think what I'll do is I move the previous gear to be within the scope of the I loop, like so row level, so it resets every row. And also the next thing I need to do is if we don't find a number, which is this, we say previous gear equals 0. So if we do go for a dot, that accounts for this edge case here, 2.2, which could be valid. If we do this, we get 6084. Let's do this on the example. Yep. 467, 467,835, and then this finally. Okay, that looks familiar too, but okay, that took so long. Oh my god, that took forever. I've got like day 3. Are you serious? Like, just out of curiosity, let's have a look at what day 3 for this one was for 2022. Like, oh, we're looking for characters. They had us looking for characters and repeated characters. And then this year, my God, I'm scared. I am scared of days to come. I know it's the weekend and they make them harder on weekends, but yesterday was a breeze. Like, and day 1 wasn't that hard. Like, it was fine. Wow. Well, if you made it, this must have, I don't know when I started. Must be a while now. So yeah, thank you if you made it this far, and yeah, see you tomorrow.